Great. Now I've also started recording. All right. So let's start from where we left. All right. So I think what we should do, Anusha, is are you comfortable with any programming language? Have you even 10 years ago or earlier have you coded or something like that? If you want, you can unmute. I don't think there is anybody else in the session. Yeah. So, are you comfortable with coding? All right, all right. No worries. So, what will I do is, have you been able to log in into our Cloudlex Labs? All right, let's log in into Web Console. Okay, and let's try to. Your login will be different. Mine will be different. Or maybe what we can do is go to H3 at this. Okay, go to H3 and here you copy paste your login. Sorry, sorry, here, and you copy paste your password and you'll be in your shell. All right, are you with me?
Yes.
Great, great. Now just type Python here. All right. In case you get stuck and there is no way, I'll make you the presenter. So we will keep this exercise. Why is it not available to you? From yesterday onwards, CloudX is not available. It says, what kind of error it says? Update is not available. Is it? Error encountered in okay, okay. So what you do is I'll just send you my login password. So I've given you the URL, open that one. I am going to give you my login password. This is login because it's not getting because chat does not get recorded in the video. That's why it's okay to put it on the chat. All right. So are you able to log in now? You use it for some time. I'll re-enable your account. It seems that earlier we had by mistake enabled people's account only for 10-15 days. Okay. And also let me put in a to do enable Anusha's account. All right. CloudX. All right. Good. All right. Sounds good to you? Cool. Now, are you able to log in into this terminal like this? So after logging in, you can type Python and let me increase the font. Good. Are you able to see this kind of screen? H3, H3, this one is not opening. So before we move on to Spark, I like to I like to go through this Python thing. Okay. Because Mehdi has been part of our Spark session, he may not need this, but other users of this video will be able to see this. Okay. Are you able to log in now?
Yeah.
All right. So you are in this after dollar sign, right? Okay, good, good. Now let's say I'm here. I say Python, correct? You see that Python 2.7.5. So this is a Python console. Just like on an SQL console, we write queries. Here, we will write the Python statement. Okay, Python statement means a simple a kind of either they are of the form of A equal to B or they are in the form of 3 into 4. Okay, I'll show you more about it. All right, so here we will be writing Python code, and whatever you write, if you gather it in the same sequence and put it in a file, it becomes Python script. Just like Unix shell script is basically you take all these commands, put it in a file, and then run, and then it executes one after another. In the same manner is your Python script. Okay, so if you learn this, then you'll not have any problem in writing any Python code. Also, before you get intimidated by coding or any kind of thing, Python programming is probably the most simple of all the things. Okay, Python program is a simple expression like this, starting with simple expression like this, saying 2 plus 3 equals to 5. No big deal. Similarly, you can assign 2 plus 3 to this x. Now the value of x is 5. See that? This is probably the most simple program. So whatever you type here is is an expression. A single variable called x is also an expression whose value is 5. And when I say 2 plus 3 into 4 plus 5, okay, so that's also an expression. Get that? All right. If we want to do more operation like complex operation, we can utilize the available libraries. For example, if I want to do some advanced maths, so I can use this math package. And what are the package available inside math? Whatever functions are available, we can have a look at them by saying dir math. Now it shows us that, oh, this has got power, this has got pi, this has got radians, this has got sine, this has got square root. So let's try square root. Okay, math dot square root. It says it's a function. Okay, so we say give me the square root of 4. It gives us 2.0 and 50. All right. So this is our Python console. So either a variable, a number. So when I say x equals to 45, x is a number. Or it could be a big number by saying 45.0, it's a big number. Or it's a decimal number. So or x could be x could be a string, like I said x equals to Sandeep. So x is Sandeep here. If I want to say x0, it means I'm trying to access the zeroth value of this x. And what is a string? A string is nothing but a number of characters, yeah, number of characters arranged in an array. Okay, character array is one. Also, I could say some other variable equals to 1 comma 2 comma 3 comma 4. All right, so this y is now an array. Okay, array of integers. I can do a looping over y for saying for I in y, and then say print I into 30. So I have just multiplied all these numbers by 30. Or I could also say things like this. So if I want to repeat something 30 times, I can do something like this. All right. Now, so this is my array, and I have been able to do a couple of operations. I was able to iterate through an array. In the similar way, if we want to create an array of strings, we can say something like this. So what is an array? Array of something. Array is a list of things. Okay. So names is list of strings. Also, please note that array can hold different kind of objects. You can see that. Now names has got first is a string, second is a string, third is a number. Okay.
Okay.
So when I'm assigning something to something, it means I'm giving a name to this particular thing in the memory. All right. Similarly, Python also provides objects and classes. We will not get into objects and classes. It's unnecessarily time consuming, which will not be needed too much in the beginning. Okay. So there is an array and there is a, so we talked about a simple expression, very simple expression, then how to import a package, how to find out the variable inside the package. Okay. And we also talked about what is an array and how to do. So there are many operations which are provided over an array. So you can see that, you can quickly see that the you can see help, and it will show you all the things that are provided over an array. You see the reverse function. So let's see what happens in case we do reverse. Okay, so what happened with reverse? Yeah, reverse, I think in place it reverse the order of things. Okay, you see that? And if I say names 0, sorry, names 1, names 2, so you can see that I'm starting with 0, not from 1. All right,
Yes.
so now here you can say things like reverse, and it will reverse. Sorry, is it? String doesn't have a method called reverse. That's strange. I thought it has. Oh, it doesn't have. All right. So if you want to see all the methods available on an object, you could always say dir. If you want to order things in an array, you can simply say names.sort. Now you see, it has ordered the names like this. First number, then SA, then SS. If I say append to, is it append? I think it's append. Say I put apple. Now names has four elements in it. Now if I say names dot sort, okay, and then say names, so you can see that it has ordered things in alphabetic manner. Sounds good.
No.
Okay, so did I move too fast?
No.
Everything clear so far?
Yes.
Okay, okay, so what are the things you are able to do so far? Right, I'm okay even if you want me to begin from starting. I'm completely okay as long as we are on the same page. It's okay, you are not wasting. It's okay because other people might also feel in the same way, because since I have been coding for some time, that's why I may not get good idea about whether I'm going fast or slow, or I'm
No.
okay. All right, great, awesome. So no doubt so far. So here we have names, which is an array of elements. So I talked about basic data types, numbers as in decimal, integer numbers, which are integer means which are doesn't have decimal numbers, and then we talked about strings. Then we talked about array of things. Array is like a list of things, and you can iterate over names. So if I say for n in names, okay, I can do something with n. Let's say I say, what can I do with this? Okay, let me try to do len, because integer doesn't have len on it. Uh, okay. So now my names has got a number. Let me remove zeroth element from it.
Remove of.
Uh, I can say I can say delete names. I want to delete the zeroth element. I think, isn't it correct? Uh, do I do this way? Yeah. Uh, Let me see. I keep confusing other languages with it. So do you see insert, pop, remove? Okay. Remove. So when I say help names dot remove, what does it mean? Removes first occurrence of a value. Okay. So I can say names dot remove. Can I remove none? I don't think so. Did it remove? Good, it did remove. All right. None means none is also kind of a value. None means nothing. Okay. So if we want to say a particular value is nothing, we can say none. It's neither a number nor a string nor an array. All right. Now there is third kind of objects which are called tuples. Tuples are very useful. Tuples means I can define things with round brackets like 1a comma 1 comma 3. Now the thing with tuples is either you cannot modify tuples. It's a read only thing. You cannot remove like the way we did remove zeroth element. Okay, all you can do is reassign it to something else, but you can access like zeroth element and then first element like that. Okay. So tuple is just like an array, just that it's non-modifiable. You cannot modify tuple. You can see things like what is it that it provides. It provides you count and index. Forget about the variables which are starting with underscore. These are basically representing internal operations like plus, minus, equal to, format. So if we have t and we want to say t equals to 1 comma 3, it says true. So in the similar manner you have if conditions, while conditions. So if I want to say if t equals to 1 comma 3 and say print high, so it shows that high. And in case I say print hello, and then I say else print oops. Okay. So if I do that, you can see that. Now if we want to do the same thing, so in case t was something else, it would have printed oops. So this is if condition. Similarly we have something called uh, normal while loop. Okay. I equals to 0. If I want to, you know, while I less than 10, if I want to say, okay, if I want to say while, wow, what a mistake. Yes. All right. I want to say while I is less than 10, print I into I, and then I equals to I plus 1. So it will go from 0 up to 81. Why? Up to 9 basically, right? I will be 9 and it'll be printing I square. So we were able to quickly code something like this. So we can basically do lot of wonders just with this small knowledge of loops. So we quickly covered two kind of loops. One was for. For is kind of you iterate over list from left to right. Okay. For is a definite loop. So Okay, for is a definite loop. While is indefinite, as in if you mess up the condition here, if you mess up the condition here, you might end up with infinite number of iterations. Okay, while for loop, you just said for name in names and do something, let's say print length of name. So it just printed the length of each of these strings. All right, so you could do lot of magic just with this information, and rest of the things so this was just the basic knowledge about the programming language. We talked about the basic data types, arrays, the tuple, then we talked about loops. Now the next thing is functions. Functions are nothing but bunch of statements which can be executed again and again. You can pass some variable to a function and it can do things. Or the other way to look at a function is it's a small machine. Okay, it's a small machine to which you give some input and it gives you the output. Just like a computer takes some input and gives the output, in the same way you can look at a program takes input and gives output. In the similar way you can look at a function. So function is basically a program is representation of a computer which takes some input and gives output. Similarly, function is a representation of of a computer where it takes the input, gives out the result. For example, we said math.sqrt and we said 10. It means it's taking 10 and giving out the square root of 10. Correct? So that's a kind of a routine. It takes 10, gives out something as the return value. We can assign it to something and then we can say print x. Or we can say print x into x. It should give 10. All right. So basically, everything, if you look at it, addition, multiplication, everything is under the hood of function. That's why when I say dir x, which is a number, do you see here? It's a hidden function inside this variable. Okay. So every operation is basically a function which takes input, gives out something, whether it's a operator or something else. Perfect. So functions are integral of any language. That's why we always address lots of Python or similar languages called functional language. These are functional, as in they have functions in them. It is possible to have constructs absolutely based on functions. And with functions, you can organize your code really well. Okay. Uh, so are you with me, Anusha, with respect to defining functions? All right, great. Now let's look at something. So there are two more things I like to address, and then you will. So functions can also be passed into functions that I'll show you. Okay. So let me first define a very simple function. Let's say my what do you call? Um, what do we want to do? We want to let's say we want to add. Okay, we want to add x and y. So you see the colon here, and also notice the tab. Okay, whenever we are defining a block of code, just like here while defining for loop and while defining while loop, here just while defining while loop, we had a tab space. Okay, so always put a tab is a way of marking that my block is starting from here. So anything from here, if it has a tab, it's part of the function called add. Okay, otherwise anything which is starting from here and has a tab in it will be considered as a part of this function. If you end the tag, the Python will think that you have finished writing the function and function definition has ended. So here I'm saying return x plus y. Okay, so I can say add 4 and 5, and it will return me to one value. Now there is another function. You can also return multiple values from a function. Let's say I'm defining a function called um, order two values, which is taking x and y in argument, and it is supposed to order them in increasing manner. Okay, what will you do? Yeah.
4 and 5.
Yes. So I want to order the whatever argument is being passed to order. I want to switch them. Okay. So let's say I'm saying if x is greater than y, then return.
Print.
I'm putting a bracket here. Notice that. Okay. Return. Sorry. Y, comma x. All right. And then I say return x, comma y.
Y.
Okay, now if this condition is not if this condition is true, that means it will return from here and will not
Perfect.
go, it will not go here. Perfect. And then
Yes.
if it fails, then it will return the second one. All right, and notice this bracket. You know what is this bracket for? These brackets are to mark it as a tuple. We could have returned it like an array, right? We could have returned it like an array, but we are marking it like a tuple. Tuple is like similar to array, just that the array is modifiable while tuple is not. Okay, you can only create a new tuple out of a tuple, but you cannot go back and change. So tuple makes a very good way of passing things to functions, so that function inside does not change the input. Okay, I'll tell you what do I mean. Okay, so uh, i'm get- I'm getting a little feedback. Do you have a headphone?
Yes.
All right, great. I'm hearing my own voice. All right, for time being I'll just mute. All right, so here I'm saying order, and if I say 5 comma 6, it'll return 5 comma 6. If I say 6 comma 5, it'll return 5 comma 6. And similarly, if I say Sandeep and Giri, it will give me Giri comma Sandeep. Okay, because strings too are comparable. They too can be compared in the same way, the way we are comparing the numbers. Perfect. Now sometimes, so this is two variables we are passing here. All right. The problem could have been far more complex had we been passing a indefinite number of values, like had we been passing an array here. All right. So that is how the functions operate. Functions can return multiple values either by the use of arrays or by use of tuples. Okay, or by creating objects. Objects we are not going to cover. So we were able to define the function, we were able to execute the function, we were able to write a loop, we were able to write a condition, and we were of course able to write expressions. Perfect. Do I make any sense, Anusha? All right. Yes. So good. Good. So that was a quick overview about Python. Do you want to give it a try, and then if you have a problem, we discuss it right away? I have muted you. Okay. So you try and let me know when you want me to continue. So this was a quick overview. This is a quick overview of Python. Let me just think if I have missed something. So, all right. So we talked about, okay, so here this is something else. We'll discuss that later. Okay. So we talked about first expressions. Uh, I think I should have been more structured. Yeah, but generally the structured way becomes very boring for everyone. So we talked about data types, as in there are something like yeah, and then we talked about expressions, we talked about variables, and we also talked about functions, arrays. We talked about arrays, and then all right, that sounds great. Now there is a what was it? Yeah. So sometimes you want to assign the output of the functions. So we can always assign the output to another tuple saying x comma y equals to this. Now, whatever is the output of this order will go into x and y. You see that? So, so yeah, Giri went to x because after ordering, Giri will come first. So Giri went to x, Sandeep went to y. All right. Now, there is an interesting aspect of Python. Please note that I'm talking about Python right now. So the idea about and also we talked about import. We talked about yeah. All right. Now let me talk about something called MapReduce. This is something very interesting, and you may be able to get the taste of it just by looking at these things. All right. Now let's say you have got a big array. Let's say you have got one, two, three, four, five, six. Okay. You have got big array with you. Okay. Now you don't know what are you going to do in future. So like okay, let me just get jump into MapReduce. Okay. So there is a something called map. Let's say there is a big array called A which has got some numbers in it, and you want to do something with each value of this array. You want to do something with each value of this array. So let's say you want to do a square root of each of these values. Now you don't want to write a for loop. You don't want to write a for loop. Okay. In those cases, you can write something called map. Okay, how can you do that? You can say map A. A is the input data, which is the array. And we could write, we could write what? We could write, we could pass a function called math.square root. Okay, it is the other way around actually. So we are applying math.square root on A. Okay, so this map is a function provided by Python itself. And that's why when I was talking about MapReduce, I think I mentioned that MapReduce is a paradigm that has come from functional languages. So functional languages had this MapReduce paradigm for quite some time. Okay, so for example, here we are saying math.square root and A. What did it do? It basically took one each value of A and ran math.square root against each one of it. Okay, so if I have to represent it diagrammatically, it'll look like this was our input, this was our input, Okay, and this is our output. Do you see that? Good. And here, let me try to see if I can make it fit here. All right, good. Now you can see here, let me reduce some of these decimal numbers. I just shortened these numbers. Okay. All right. So this is our MapReduce. So got translated, one got translated into 1.0, and 2 got translated into this, 3 got translated into this, 4 got translated into this, and so on. Okay. So the math dot square root was applied on each of the function. So you did a lot of things without actually defining a function. Okay, you did a lot of things. So your function got executed without even you knowing it. Okay, so you iterated over a without actually writing a for loop. So if you have to quickly do something with the full array, you can do these kind of operations without writing this. Now, there is an interesting aspect of this map function. What did map do? What did map do? Map took the headache of iterating over the values from you. Okay, now inside map, whether it's doing it from left to right or doing it parallelly using hundreds of threads. When I say hundred of threads, if a computer has 50 processors, map internally might do things, right? You don't know. So it has taken the headache from you writing all that logic and have solved the problem for you. That's why this map function became an idea which basically hid the logic. It has hidden the logic of iterating as in, it doesn't matter to me whether it's iterating from left to right or right to left, or it going till middle, and then from middle it's going from both the sides, or it's running two two processes parallelly, one going from left, other going from right, and as they meet in between they'll finish. So map has hidden that logic from you, and therefore this map is a paradigm which was provided by these machineries, which they implemented in their own way. And that's why Hadoop has its own MapReduce, and Spark has its own MapReduce, and we also talked about MongoDB. It has its own MapReduce, meaning it doesn't matter the way they are applying your function doesn't matter to you. What matters to you is uh, your function. What kind of transformation do you want? So that complexity is taken by you and absorbed by the framework. So it's the responsibility of the framework as how to do the map. Okay, so you can see that. So here, if so map basically took the headache away from you. Let's say we had a, and now we want to compute something like something which is not there. I want to do is I want to multiply each value by 4 and add 5 to it. Okay, this is what I want to do. And also if I have to comment something, I can put hash in front of it. Okay, this is comment actually. When I put a hash in front of line, that whole line is commented. It's no longer regarded as something. So let's say this is what I'm interested. So instead of writing a loop, I'll write a function. some function. Let's say um, m for add 5. That's my function name. And whatever value I have, I can return x into 4 plus 5. Now, m for a5, if I say x, not x, I say 10. You can see 10 into 4 plus 5. Perfect. Now, if we want to execute this function on every variable here, we can simply say map not map, m for a5. That's our function name. I just wrote the craziest function names over. You can see that it has done the magic for you. You did not have to write the for loop. You did not have to iterate over these values. Therefore, this map function is quite useful. All right. All right. A quick question to you. What is Fibonacci series? I actually don't know the spelling of it. Uh, so do you know what is Fibonacci series? All right. Yes. Go ahead. It'll be 1 plus 2 plus 3 plus 5. I think after 3 it will be 5, not 6. So so nth value is sum of n minus 1 and n minus 2th value. Huh. Yes. It's or sum of previous. This is probably better way to say. Sum of previous values. Okay. I'm typing on the command prompt itself to facilitate. Okay, good. So it's not all previous, only two previous values. Okay, only two. So it'll be 1 comma 2 comma 3 comma what do you call 5 comma 8 comma 13 and so on. Okay. So it's like saying it's a natural progression where there is a man, woman, and addition of that becomes kid. The addition of and so on. Sorry, that was a bad analogy. Let's think about something else. So okay, let me try to write a function Fibonacci. Okay, it will generate the Fibonacci series. Okay, so you will say Fibonacci series up to n. Okay, we'll say up to n. Okay, and we will start from 1. Okay, so how will we do that? What exactly are we trying to do? We are trying to print Fibonacci series up to n. Okay, or yeah, let's say up to n, as in as long as we don't exceed n. So we say if, all right, so I'll say previous equals to 0. Okay, so I'll say previous two values, I'm assuming one to be x and other to be 1. Okay, so I'm saying this while y is less than n. So I'm saying while the second value is less than n, do this. Okay, so new value, new value equals to x plus y, and then we are saying Now we are assigning this. Uh, so new value goes into y. What was there in y goes to x. X becomes y, and sorry, the mistake again in that. Ouch, that's the only problem with the console. I'll have to modify. Okay, so let's try to write here. Okay, I think I'm more comfortable writing in here and then. So this is what we're trying to do. We are saying Fibonacci. Okay, good. Also notice the tabs. Okay, I'm putting tabs like this. So x became y, and what did y become? The new value. All right. So now that's pretty much good. Cannot assign to literal. What? Oh, oh. Okay. Or easiest way to represent the same thing. I'll show you some cool thing. X comma y is equal to y comma this. Good. So here we are saying x becomes y and y becomes x plus y. Let's see. I have never tried it. I would like to give it a try. What is wrong with it? Uh-oh. We cannot define the variable like this. We can define variable like this. Let's see what happens. All right. So I have defined a function. Oh, oh, we were supposed to also print, right? We were supposed to print. We'll say print x comma y. Will it work? Fingers crossed. Oh, okay. All right. So it has printed 0, 1, 1, 1, 1, 2, 2, 3. Okay, good. Instead of printing x and y, let's just print x. Good. Let's just print x. 0, 1, 1, 2, 3, 5. Because 5 is less than 10, and okay, so next value was supposed to be. So I'm saying 5 plus 3 is 8. Oh, it's basically printing y. It's basically printing x. I just changed it to y. No worries. So let's say I say fib and I say 15. See, 1, 1, 2, 3, 5, 8, 13. Good. So this is Fibonacci series. I don't remember if 0 is included in Fibonacci. I think it's only from integers from 1 to onwards. So you can see if I say really big number, you can see a lot of numbers are going here. But it quickly has become this big. Okay. So if I want to say, um, okay, so let's do something really interesting. Okay. I define an array and whatever is the output. Okay. So is this clear to you, Fibonacci series? Uh, Before I jump into anything. You want me to copy paste this code onto this window and you want to try? The bad news is that, okay, I'll do better things. I will save it here in in the this called fib.py. Okay, and All right. So I can actually say fib.py. Uh-oh. We have now no main function there. We should have had main function. So you can have a look at fib.py in the command line there itself. Fib cat fib.py. You can see. Okay. So are you trying from the howsoever you want? You can try from the console. So there are many. Fibonacci series has been very interesting thing. It basically gives you an idea that rich gets richer, meaning when the numbers grow bigger, as the numbers keep on growing bigger and bigger, the the numbers keeps on increasing really fast. Initially, it was increasing really slow. At one, it did not even increase. One remain one, and then it increased to two, and then after some time, it starts increasing really fast. You can see that. So the property about Fibonacci is quite an interesting way to study, and I'll explain to you why I'm talking about Fibonacci. Because Fibonacci is kind of a program that you cannot run through MapReduce. Okay, did it work for you? Okay, what we'll do is uh, we will take a 5 minutes break, and then by the time you can also give it a try, and then we can continue the discussion. All right. All right. I'm back, Anusha. I'll make you the presenter, and then if you have a headphone, okay, then I can guide you. Okay, make presenter. All right, I have made you presenter. So you can share your screen and all right, good. Okay, okay. So you, yes, you do this here. Yep, yep. Okay. So you were doing correct here. You say def. Okay, go to the last line, press enter. This is the last line. Okay, delete everything. Press Control U. Control U. It should delete. Or just press enter. Okay, just press enter. Yeah, good. Now write def fib n colon enter colon not semicolon. You can press up arrow key to see the previous one. Colon, yeah, enter. Now press tab. Press tab. Don't type actually. Press tab. Yes. Enter. Press tab. Not here. Only one tab. Yeah. Good. Enter. Tab. No, no, no. You have to press tab. Colon. Now you have to press double tab. One more tab. Yes. Print Y. Space. Yeah. Enter. No, no, no. Enter. Say x bracket x comma y equals to y comma x plus y. Enter. Enter. Again enter. Good, good. So you are able to write the code. Now you can try executing this function. You just define the function called fib. You can try with fib5. Yes, see that? Now you can try increasing this number to a very large one. You can try executing it with a very large one. Good, good. So it's working fine. All right, all right, good. All right, so yes, okay. So we talked about let me make myself the presenter and then all right, brilliant. So you were able to do the write your first code in Python. All right, that was good. All right. So what we did just now is we generated a Fibonacci series. Now, generating this Fibonacci series is not really possible with map or any distributed computing because individual operation is not independent, meaning always whenever we have to generate a particular number, we need previous values. So the next one, the generation of a number cannot proceed unless we know about preceding two values. That means it is not possible to make it parallel. It's a sequential operation. Sequential parallel is that we can do things like we did square, right? The way we squared all the numbers, or the way here we computed the square root. It was a parallel, as in it doesn't matter for four's square root to know what was the three's square root, right? It did not matter. Okay, so it was a fairly easy to do with map, but things like Fibonacci series are impossible for any big data computing. Okay, doing Fibonacci series is almost impossible with MapReduce. Okay, so here was our map function, and we wrote Fibonacci series in order to display that. Uh, in order to talk about that why Fibonacci series is not possible with our usual methods. So here we cannot use a Fibonacci map method to generate a Fibonacci. Now we talked about map, right? We talked nicely about map. So map basically translated one value into another value. It's a one-to-one relationship. Now sometimes you might want to combine these. Okay, you might want to combine these. You might want to combine all of them together. For example, you might want to do summation of all these values. Okay, you might want to do summation of, say, let's say our array is 1. Okay, I think I can just copy from here. So array is this. Okay, so if I say sum of array, it gives us this. Or maybe I'm looking for max of a, or maybe I'm looking for min of a. Okay, so in those cases we am able to do this kind of a summary operation, right? Or maybe I'm looking to compute average of a. All right, so average of a is not there. All right, so when I want to combine all these values into a single value, then I use a function called reduce. Okay, so let's try to do this. What was the function we did? Order, right? Order. Let's try to write our own function called um what do you call? Let's just write our function called sm. It takes two values. It's take only two. Please note, it takes only two variables, and it returns x plus y. So here we can see, we can say sum 4 5, it sums. No big deal, but yeah, let's say we have to compute the summation of our array called a using this function called sm. In that case we can simply use a built-in function called reduce. To reduce, we say here is my function and here is my array, and it returns the summation. What did it do? What did it magically do? You see that? It computed the summation of the whole array using a function which takes two arguments at a time. How did it do that? How did it do that? Do you see that? Using reduce, we were able to compute the summation of the full array Okay, quickly. Or let's say we say reduce, and we have defined another function called mymin. Okay, it takes two values x and y and returns, okay, if x greater than y, okay, return y, else return x. Okay, so it basically, this your function min is nothing but a minimum function. Perfect. Now let's say instead of summation we want to compute the minimum of the whole function. Okay, see, you were able to quickly compute the minimum of the full array without having to write a loop, without having to you to apply your function again and again on this array. Reduce did the job. If I had to do the same thing, there were two ways to do. One way was to recursively call min. What do we mean by recursive? Recursive means a function calling itself. Okay, for example, let's say I'm defining a factorial. You know factorial? Good, great. So defining a factorial like this, factorial of x is basically if x equals to 1, no brackets, no brackets needed. If x equals to 1, we say return 1, else return factorial of x minus 1 x into x minus 1. So it's so easy to write a factorial function. And you can see that if I say 1, it'll give me 1. If I say 2, it'll give me 2 into factorial of 1, that is 1. If I say 3, it will go here first, then compute factorial of 3 into that, 3 into factorial of 2, and so on. It'll keep doing that. See that? And I can simply compute a really large factorial. You see how big the number is? Factorial of 400 is so big a number. So that's the magic of recursion. We just wrote two line of code to do a computation like factorial. All right. So that was our recurse example of recursive, because I realized that I have not covered a recursive function. Therefore, I talked about recursion. All right. So now we have reduce function here. All right. So there were multiple ways to run. There are many ways in which I can compute the summation or minimum of these values using my sum function. One way is I first compute sum of these two value, then sum of these two value, then sum of these two value, and then do again and again on remaining two values, right? Other way to do the same thing is I pick up the first value, then do the summation of these two, then these two, then these two, and so on. All right. Now, so both these functions are magical. Map function is magical because inside map, if what Spark guys did was they did something really clever. What they did was inside map they were running. If your computer has multi-core, as in multiple processors, it will run map of these two numbers on one computer, these two numbers on another, and this on another. So and if you have a billion numbers, they were able to do this for a billion numbers. So that's the magic of map. Inside map, the way their implementation goes is hidden from you, and they have done all kinds of hard work in the way the map function does the magic. In the similar spirit, let's look at the diagram. How will my how will my reduce work? Let's take the case of these four values. Okay, I'll try to create 1, 2, 3, 4, and 5. Okay, so we had a function called sum. We had this function called summation. It was taking two values, this and this. So this is called sm. Sum was taking 1 plus 2 and generating 3. In the same way, it was, how do you copy? All right. Or maybe, yes. So you can see that it might have been doing this kind of computation in many ways. Okay. So let's say this goes 7, this goes 10, and then it might be something of this sort, where this method is going to be something. Do you see that? So this computation, this diagram means first your sum function was taking only two values at a time. First your sum function was executing on these two values, and then whatever is the result, then this, and then this. So what we see from here is your function is being fed the output of your previous function. It's like those chain reaction. You remember those chain reaction in which one cell, one reaction of one output is the input to the another reaction, right? So basically, single function led to so much of computation, and the only thing you have to remember is not every function can be used for reduce. For example, average, the function called average, we cannot use in reduce. Why? Let's try to do the average in the same manner. 1 plus 2, the average is how much, Anusha? 1.5, right? And 3 and 4, the average is 3.5. 3.5 and 1.5, the average is 3 and 4 and 5. It is 2.5. Good. So far it is good. Now the average of 2.5 and 5 is how much? 3.75. Is it right? Is this correct? So now you see that we try to do the computation of average in the same way, the way we are computing this thing. Now what do we see here? What is going on? So if you do the computation of this, 5 plus 1 6, 4 plus 2 6, and 3. 3 plus 3 is how much? 3 plus 3 is 6 plus 3. Okay, 6, 18 plus 3 is how much? I'm just trying to compute the average. So yeah. So let me say summation of 1, 1, 2, 3, 4, 5, correct? Divided by 5. And please note that it's giving 3.0. And why is it giving 3.0? Yeah, it is 3 only. So the average is supposed to be 3, but here, as per our computation, it is wrong, right? This is wrong because average is not a good reduce function. Average is not a correct reduce function. Because if you apply average again and again on the same input value, it will give you the wrong result. Therefore, not every function could be used as reduce function. Make sense to you? And here we are still talking about Python. And this we were trying to create, check if our average function is like correct or wrong. All right, good, good. All right, so that was a good introduction for of Python. We also talked about MapReduce. We basically try to use two functions called map and and reduce. Okay, we did map and reduce. Also, if you don't believe me, let's try to define our average function, which takes two values x and y. It returns x plus y divided by 2.0. Notice 2.0. Why are we doing that? So that because if you say 5 by say 4 by 3, it's always 1. Okay, to have the correct decimal you have to write something like 4 point, either of the number should be marked as decimal, only then you will get the right output. See that? Therefore, in the same way we have written our average function. Correct? So average is doing good. Just that, if we do reduce and we pass our function and the array, we are trying to compute the reduce, and which is not right. Okay, so is it right? It is. So let me do summation of a divided by length of a. This is not right, right? Correct. So this is 3.5. Okay, while our actual average is 4.5. So our reduce function has returned this value while our actual average is 3.5. Do you see that? Therefore, the reduce function, no matter where, is not a logical way of. Not every function is a valid reduce function. Only those functions where no matter how you combine two values to give a single value, so that is your function. No matter how you combine your values, whether if you keep on combining again and again, okay, still if the output is correct, then your reduce function is correct. Okay, so what did we talk about? We talked about two things. One, map function of Python or any functional language helps you apply one function on all elements of an array without you having to deal with each individual nitty-gritty. Okay, and that function was good in the sense that it has hidden the complexity of looping around the array. Okay, and that has given birth to the frameworks like Hadoop's MapReduce and Spark's MapReduce. Similarly, the reduce function, which basically applies your function again and again on values of an array unless you get a single value. the signature of reduce function, the reduce function, we are talking about your function which you are passing to the reduce method. The function you have passed, that function should take two values in the arguments and return single value from that function. Okay, sounds good to you? Good, good. So that was our neat way of doing on quick work on Python shell. All right. So now let's jump into to Spark. We covered the theory aspect of Spark in yesterday's session. Okay, some of the theory, not all. I think we only described the architecture. Where were we, by the way? Anusha, do you remember? I think I'm kind of forgotten. We talked about this. We talked about resilient dataset. Did we go to transform? No. All right, no worries. Good. Now we are exactly in the right direction. I wanted to be at this slide as soon as we finish our map reduce. Okay. All right. So what we saw just now, we had an array which contained numbers and we were applying function on it. The difference, okay, I'm little more stretching here. I'm little more stretching here. So here, if you see, we did not need to bring, uh, okay, so when we were applying our function on a data using the map function, when we said map, so it suddenly changed the way we look at the programming. Instead of you bringing the data to a computer, you are handing over your function to the computer. What we did here, if we see here, where was my map function? Where was my map function? Did we talk about map here? Yes, here. So what did we do? We handed over, we handed over the map function, our map function, whatever we want to apply on each node. Okay, and let somebody else's library decide how to apply it. Okay, so essentially we opened the door to carry the code to the data rather than bringing the data to the code. We math.square root did not access the variable. It only We just wrote the logic that this is how we should be translating data and hand it over to the framework and say that it's your job, and you apply my function on every element of this array and store it in another array. Okay, keep this in mind. So again, I like to stretch it a bit. Okay, so you can always imagine that you have this big array. It contained something like good objects. Okay, let me just be a little more dramatic. All right. So yes. All right. So it has something in it. Can I draw it with a solid one? All right. Let me just. Yeah. So it has some data inside it. All these variables had some data inside it. Okay, and it was being converted into another value, something else, okay, from here. Okay, it is being converted into something else. Okay, I'm just putting some things here. So it's converting from here to here. Okay, all right. So here, what was it? It was basically our array called A, and it is getting converted into something, some other array. That's what our code did, right? Now, what if this array is located on hundreds of computers? And that's what Spark did. Spark guys thought about it and again, and then they came up with the idea that what if we took an array and spread to hundreds of computers, okay? And then we give the user this function called map, and using which they can translate the data, they can churn the data, using your own function. The users could churn the data using their own function, and that's where the birth of RDD took place. They defined an RDD called Resilience Distributed Dataset. It's basically a huge array, whether in memory or just a symbolic array. It's a pointer to some data which is lying somewhere. Okay? And they made this array such that even if the computers holding parts of this array, if those computers die, some other will take place. Okay, so this is called resilient distributed dataset, and that's where the whole idea of this computing revolves around. So whenever we talk about data churning or data analytics, we first talk about data and the representation of data. In case of, let's start with the various systems. So in Python, you can think of data as array. Okay, data is plural word. Therefore, we're talking about an array. Okay, so in Python, data is an array. In databases, data is your table, right? And in case of R, the data is data frame. And in case of MapReduce, it was the input file, or we call it input split. Okay, basically they created a list of blocks on which we were applying the function. So it was input split, we call it input split. All right, a list of input splits. We are talking about Hadoop. So you can see that every technology which churns data, or which basically does some kind of analytics or processing on data, they have a presentation of an array in the form of something. Similar is the case with Spark. Spark has RDD. Now the beauty of this RDD is it is on in case of relational database, a table is in this computer, it's not on hundreds of computers. But in case of Spark, this array, what we're saying that this is a big data set called resilience data set, it may be on hundreds of computers, it may be in the memory, it may be in the disk, but it is a representation of a huge data. Now how do we churn this data? How do we churn this data so that the complexities of operations are hidden from the end user? The complexity, whether this data is on one machine, two machines, or are we running it as multiple processes parallelly, or on the same computer using different threads or using different CPUs. So if it doesn't matter, and so it should not matter to the end user that how it's being done, and that's where the idea of RDD started. So RDD provides you the functions like MapReduce, which can be executed on it. Okay, so inside an RDD you could store an array. Each value has to be an object. An object could be a simple number, it could be a array, this could be a tuple, key value pair. This could be a dictionary. I forgot to explain what is a dictionary in case of Python. So sometimes you have to define key value pair, like you have a dictionary where the word and a meaning. So you could define things in this manner. You could simply say a, and then you could say the key is name, and value is Sandeep or Sandeep Giri. Okay, a is the key is age, and the value is something like 35. All right, so you can see that we have been able to create kind of an object with flexible names. We could put any names and put the value. This is dictionary. So coming back to what I was talking. So in RDD, in the similar way, each element of this big array could be anything, could be a dictionary, could be a large object. Although we have not talked about object, but just imagine that we can create objects in it. So we'll talk about custom data types. All right. So also please note that just like how should I just like in our map operation, we inputted an array and it gave us output. It did not modify our data. In the same way, RDD is a read only. We generate another RDD from one RDD, and so on. We write our whole analytics program as number of steps. We are saying that first take this array, load it, and then translate it into something else, then translate it into something else, and say, keep on doing it unless we get the result. All right. So we can start loading the data in this manner from the Hadoop distributed file system like this. Okay, so if you are comfortable with 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 this, let's start quickly our Python console where which is connecting to Spark. And there is a command called PySpark. This is the command line version of Spark, and it's basically the same console what we have talked so far about, just that there is some extra operations happening before launching this program. What are those extra operations? It's creating these three extra variables. One is SC and other is SQL context. So it created these two, three variables before launching our Python programs. Now here when I say SC, so it has predefined this object the way we had defined our variable. Similarly, what did Spark do? Spark basically created its variable before Python loaded for you, so that this SC is available to you. SC is created by Spark. Now this SC, the Spark context, is your gateway to Spark. Now using SC, you could interact with the Spark. All right. So let's say we have an array 1, comma 2, comma 3, comma 5, comma 6, comma 89. We have this nice array. All right. This is our local in-memory array. Whenever we define a variable, it's consuming your computer's RAM. Okay. We can convert it into your RDD. You can convert it into your RDD resilience distributed data set using SC. SC is the Spark context, which is a gateway, your entry point to Spark. You are saying to Spark, hey, here is my array, convert it into an RDD. Okay? So it says that, all right. So R1 is a R1 has been pushed to Spark, handed over, sorry, A has been handed over to Spark, and in return, Spark has given you a handle to it. Now, over R1 is your resilience dataset. It says parallel collection RDD. Now, over R1, we could do our magic. And what kind of magic we could do over R1? We could do either, okay, also, if you are curious to know what is inside R1, you could say DIS. So it provides you so many things. This RDD called R1 is providing us so many functions. These are internal functions or operators. And from here, from aggregate to this. And there you will be surprised to know that there is function called map, which it provides, and there is a function called reduce. Okay, max, mean, other than that. So your R1 is the data set which you want to process in order to do some clever things. Okay, now let's take the case of our another data called lines. Okay, so it has loaded the lines as an another kind of RDD called map partition because it's being loaded. It's basically saying lines equal to sc.txt file. Sc.txt file, it converts an HDFS file into an RDD. So it has taken this HDFS file, which is located in our Hadoop, it has converted into the RDD. Now, on top of lines, you could do various operation. And let's get into the idea of what are the operations does it allow. Okay. So there are two kinds of operations which Spark allows. One is transformation. What does transformations do? They translate one RDD into another RDD. It does not bring data back to you. It leaves data on the same node where it was. A transformation converts one resilient distributed dataset into another, while the text file method or parallelize method took our local variable, con- converted it into a RDD. Now to get back that RDD, what you need to do first is you need to do before you get back the RDD. If you get back the RDD, what will happen is the data will come back to your disk again. Okay, and therefore it's not a great idea. Look at this lines function. This lines has loaded a file which might be of hundreds of gigabytes. It may not be been possible using any other means. And why it's been possible? Because we are using many computers to process it. All right. So these are called, so the way we have loaded it is it has been loaded into RDD. Now we can do operations on this. Okay. What kind of operations are possible using this? So this lines is an RDD. If you want to have a look at if what are those first 10 values of it, we can say lines dot take, we could say lines dot take t, take 10. And what did it return us? It returned us an array of lines. This is an array of lines, and the way it has represented each string is in the Unicode. That's why you see this U before the string starts. It means this string is having the character set in the form of Unicode. Okay, that is why. All right. Now you could run various kinds of functions on top of this. Okay, and you can get your work done you can basically translate this data into something. Let's say what you want to do is you want to uppercase it. And how do you uppercase it? You define your function called to up. Okay, any line you give to up will define how will it happen. Say return line dot upper. Okay, line dot upper. That's it. So to up, let's just test. Is it working? Yes, it's working. Excellent. So let's say we have this RDD and we want to convert every line into uppercase. Now, instead of using our function called map, which was there in Python, we will use the map function of RDD. Okay, what was the name of the RDD? Lines. Lines.map. Okay, lines.map. And here we are passing our function. It's saying that please apply to up on lines. Okay, that's what it is saying. Now we are supposed to assign it to somebody else. Let's say to up lines. TUL equals to this. Now TUL, when we say take 10, we're getting the data from the server and it has been uppercased. So on the surface, it looks really cool and easy, but under the hood, if you imagine that if you had hundreds of node, it will do these things quickly on those hundreds of node and give you the results really fast. Even if the data is in hundreds of gigabytes, it will utilize all these computers CPU, all these computers RAM, as well as all these computers ability to read data from the disk. Okay, so this to up function, the map function which we did, this is a transformation, is one of the transformations. There are many transformations which Spark provides you by the way of an RDD. So in the same way, you can see that map has been applied, this to up function has been applied on every line, and map is one of those transformations which is doing it for you. All right, now going ahead with this, it transformed one RDD into another, and that's what a transformation does. Now there are another kind of transformations other than map. One of the transformation is filter. Let's say we want to pick up only few values of an array. Okay, you're given an input array, you want to just keep only some of those elements, just like you have a where clause where x equals to y, or do something about it. In the same way, we have filter function. The only thing is it gives you this enormous flexibility that you can hand over your own logic to filter in the form of, when I say logic, it is in the form of a function. So you declare your function which returns either true or false. So it's like a filter, it's like a sieve which, where each hole of the sieve decides whether to let it pass or not. In the same way, your function is deciding whether to let an element pass or let an element go. So in the same way, here, instead of this, we could have said, don't let this element go. And so the way we will do is, let's say here, okay, so it did not let it go, while it went let go this one, and it did not let it go this one. Okay, so let's say we are writing a function which does not uh, let an odd value go. Okay, okay, so here the function is letting even values go. And how will you do this using Spark? So we had talked about it. All right, sorry, it has gone bad. All right, let me just log in again, no worries. h3 h3 dot cloud xlab. All right. All right. So here we are, and let me just increase the font value. And so it has created some of my value. All right, never mind. So, okay, here let's just launch the PySpark again. Let's say we have, what did we do? We'll just load our lines again. Good. So this is our lines. We have loaded our data from a file into lines, which is an RDD. RDD containing lines of a file. One element is equal to one line. Now, these lines, let's say we want to just keep those lines where the line starts with the keyword called the. Okay, so we define only, okay, only sentences. Okay, only sentences, and this is our line. And for each line, we are writing just the logic. If line dot lower, line dot lower dot starts with the, and I'm not sure if it works. Okay, and we'll just write here. So it will return us true or false, only sentences, and the. Okay, so this is good. This is false. Awesome. We are doing a very good job here. If a line starts with the, this function will return true. Okay, now let's use this function to filter out our line. Only the, okay, equals to lines dot filter, and we say on, so we are sending this function called only sentences to this filter function, and it has given us another RDD. Now to get any data out of an RDD, you have to take. You can see that it has found only those lines which are starting with the. You can see that the king, the scout, and starting with the project and the account. So you can do all kinds of complex things using this another transformation called filter. Now, all of these methods are basically generating another RDD. Okay, they are basically generating another RDD. In the similar spirit is actions. Actions take all the RDDs and bring the data back to you. Or an action takes an RDD and converts that RDD into something non-RDD. Okay, so using an action, you can bring the data back to the node. And what action have we used so far? The function called take. When we said take 10, it was actually an action which we have been running so far. If we say rdd dot length, it's going to talk to the rdd and bring the data back to you. It's an action. An action causes the whole execution in Spark. Spark has this lazy way of doing. It doesn't do things immediately. It lets you write a lot of code and then a lot of transformation. Do this, do that, do this, do that. Transform this into that. And then at the end of all of this process, when you say you execute an action, then it goes back and does executes all the transformations on which this particular action is depending. That is how Spark execute things. So the moment you execute an action, only then some action happens. Otherwise it's not taking an action, it's just making notes. It's just making notes. Okay, rdd2 is equal to filter of rdd1 by this function, rdd3 is equal to the map on top of it, and so on. So Spark keeps on making notes until you say an action. Only then it just goes back and only those RDDs are executed on which an action depends. You might have defined hundreds of RDDs, but not all will get executed. Only those RDD will get executed on which an action is depending. When we said when we said here when we said here take only the dot take, that means it will first compute only the and then only take element of those, and then in case this only the has been generated by series of transformations, it will execute those transformations. So that's how the whole magic of actions and transformations happen. This action brings the data back, and the example of actions, one of the actions was take, count, collect, and reduce. Again, here also you have reduce. Reduce keep on reducing the whole value and converts you a single value. It takes two element, do something about them, convert them into single, and give it back to you. Okay, it can reduce function can reduce the entire RDD into a single value. A single value could be something like a big string, or it could be an integer. Whatever it could be, it will be only a single value. Okay, so that is an action. All right, now let's try to find out the biggest length out of this whole file. Okay, so we'll define bigger. Okay, we have got x and y. It takes to it will say if length, so let me compute the length first, so that xl equals to length of x, okay, and yl equals to length of y. Okay, now what am I doing to do is, if xl is greater than yl, then return return the string called x. I'm trying to find out which is bigger out of x and y. So if I say bigger, here, bigger Sandeep or Giri, you can see it has returned Sandeep. Why? Because of the length. Okay, why? Because of the length. So I'm doing this strange computation. So what am I trying to do? I'm trying to reduce the entire lines to find out the biggest line out of the whole. Biggest in terms of number of characters per line. All right, now let's do the magic. So I say lines dot reduce and I say bigger. Okay, so here this is my biggest equals to lines dot reduce and use this function called bigger. Now you see lines is, sorry, why, okay, isn't that, so biggest, okay, you can see the biggest, it was correct actually, I was just looking at wrong thing. So biggest is the biggest line in this file. So If you think about it, we did something which was very, very difficult using any of the database queries. Okay, so we found the line which has got maximum number of characters. Happy? So this was the biggest line in the whole file. Good. And this is another example of running the reduce. All right. There are few more things which Spark provides. Those are more detailed functions. One is called broadcast variables. If you want to take some data to all the nodes so that you could apply more logic, in that case you can use broadcast variable. In case you want your nodes to report, nodes as in all the nodes containing parts of the RDD, you want them to continuously report back to you, then you can use accumulator. And here is a good example of word count if you want to have a look at it. And there is an example of accumulator which you can look at it. Okay, so tomorrow or on Monday, we will start with either Spark streaming or we will skip it and take it at the later point of time. Okay. I think we should talk about Spark streaming at a very later point of time. We'll just define what is it and then we will carry on with our usual analytics. All right. Anusha, are you with me? I did not look at the questions window for quite some time. Yes. All right. So we will define Spark streaming. First, we'll understand what do we mean by streaming. Then we'll define what is Spark streaming. Just remind me that we are on 18th slide in the presentation. Okay. So we'll start from here in Spark streaming. Okay. Thank you very much, Anusha. All right. I hope you enjoyed the session and please feel free to first rate the session. Second, everything what we have tried in case of Python, go through the video slowly and try to execute everything by yourself. Trust me, it is going to give you enormous amount of confidence and enormous amount of comfort with respect to the technology. And mm, if you have not coded for some time or if you have not been into coding, this will be your the time when you would really like it, because Python being such a great language, actually helps a lot of people starting. Okay, so have a great day. You will have 4 days to try things out. All right, so try out these things whatever we have discussed in the session and have a great holidays. Bye bye.